I'm Dave Coleman, Chief Product Officer and founder of PickNik Robotics. Excited to talk to you today about some of the UX work we've been doing on a pretty cutting edge robotics development platform. So it's a tool for roboticists and engineers to develop their own robotics products. It's called MoveIt Pro. And yeah, it's an honor to be here. We're actually based out of Boulder, Colorado, so flew in for this and love it when I get to visit Seattle. You can kind of think about what we're doing similar to maybe the video game industry. It's an analogy we like to use. Unreal and Unity are two popular platforms, competitors, of course, for producing video games that lots of folks from indie game shops all the way up to large titles use to quickly make these amazing video games. And it allows the designers to not have to create the same algorithmic code over and over again, the underlying game engines, the graphics, the character development. And we think this is something missing in robotics. So that's kind of our thesis. And I'll give you some backstory to this about how we got to that thesis. So we've been around for 10 years, and we've actually had something like 150 customers to date, all in the robotics industry. We started out doing MoveIt, which is a common like open source platform in the ROS ecosystem, the robotic operating system, still alive, MoveIt 2.0. But we've also now developed MoveIt Pro, which is much more of a robotics development platform. Just hit this slide. We do a lot of work in a number of industries. Space is one of them, strangely, but really exciting. We love working with our partners at Space Force and NASA and Blue Origin and so forth. But pretty much every industry, we have robots running underwater, out in farm fields, in manufacturing environments, but also in like a lot more consumer areas like cooking robots. And this slide kind of highlights that actually some of our earliest customers were in the surgical realm, but our main focus here is robotic arms. So anything that needs advanced manipulation, that's what we love. Even like we've done a lot of cleaning robots, spraying things down like for bathrooms, construction, pharmaceutical, all over the place. So going to our origin story, most people who think about robotics think about manufacturing and industrial automation. And that originated in the automotive space, and then it expanded to all forms of manufacturing, and then in the past few years to logistics, to warehouse, order fulfillment. And historically, those have been fulfilled by PLCs, which are super reliable industrial computers effectively, teach pendants for hard coding waypoints. There's all these standards that are well established and really serve a great purpose for those types of problems. And then there's robots in more unstructured environments, out in the real world, doing hard things that are changing. Not to say that industrial projects aren't hard, but there's just a whole another world of robotics that we haven't quite applied to. And it's cool seeing what Fresh has done with their robotics programs for the outdoor construction or the solar panel I think you guys are talking about. So. And typically companies who want to develop robots that are more aware of the world with more depth and computer vision and point clouds and AI models, dynamic motion planning, they end up making a fully custom software tech stack. And you pull together all the bare pieces, and it's a huge program. It actually costs quite a lot to build. It takes many years to bring a thing to market. But what we've actually seen is that most of those programs don't get to market, at least the last generation from the 2010s to the 2020s, a lot of failed robot companies. And this is true for startups in general, not just the robotics industry. But I think, talking to investors, there's been a tough run for robotics companies, a lot of them not making it. And you think about robots that have really scaled, and you think of iRobot, Roombas, and that category of robots. You might think of AWS or Amazon and their Kiva robots and all their order fulfillment. But for the most part, it's been a rough go. I gave a talk at Robo Business last year and put together some slides about failed robot companies. This list may not be perfectly correct. I certainly used some LLMs to help me with it. But for the most part, I think this is the correct list. And I have 3 slides in every category of companies that have tried and failed. And we were helping some of these actually, so got to take some maybe some blame here, but all of us, like the whole industry, we really struggle here across every sector. So it's really kind of like depressing when you look at how many failed robot companies. And what we saw is that companies were typically underestimating what they were signing up for technically, and they would have this like not built here syndrome, or they would try to like boil the ocean, and they just underestimate the complexity. And so they either didn't raise enough capital, or they like spent it too quickly, frivolously, or didn't work with partners enough, but underestimating that. And the second one, which is pretty similar to this, is like there's robotics, which a lot of founders in robotics realm have PhDs, and they think it's really fun to build that, but they're not focused on the business problem. So anyway, I forget this is a talk about UX. I should probably keep going. So we built this product to help companies ship robot programs faster and better, and like lower cost, lower risk. We noticed that there's actually a tool problem in robotics. A lot of other industries have well-established tooling to effectively ship whatever they're building, designing, engineering tools, developer tools, and yeah, it's maybe not so much that you need to hire a big staff, but just have better tools. Iterating on robotics is quite tough. I mean, that's a broad category. Of course, when I say robotics, you might be thinking about drones. You might be thinking about AMRs, the wheeled robots, or AGVs. I tend to think about robot arms, and all my slides will be about that. That's our specialty. But across the gamut, like this has been a problem of like cost overruns, being late to market, running out of runway, and we want to help fix that. So we pose that there's a middle ground here between industrial automation, which has a lot of limitations in terms of not being the most flexible, not being as extensible, great for developers, and doing a fully custom tech stack, which is maybe fun, but like it's quite costly. And so a developer platform that allows you to do both, move quickly, get a quick prototype out, but also dive into deep details if you need it. And something that's commercially supported. There's been a lot of folks going pure open source, and I was part of that. We're really gung-ho on that, but we've really seen the limitations of reliability when you want to get to a production system and you want someone to actually make sure the thing works effectively. And so the promise that we're going for is reducing your software engineering time by 75% or more. That's our goal. I think we do that for a lot of the programs, most of the programs we work with, making your developers more productive. And so today I'm going to talk about one area of our capabilities. This is probably too small a text for this room. The top section is on runtime autonomy. So you have, of course, all the very exciting machine learning models, both for perception, for grasping, segmentation, putting bounding boxes on that. There's also the versioning is a little riskier, like a little more unproven, but these end-to-end models for robotics, where we're going to put the sensor data in and actuator data out. We see great results coming from the big tech companies and the research labs and academia. I haven't seen a lot of evidence that it's 100% ready for prime time, but of course that's changing on a monthly basis. Our focus here is user interfaces for how to assemble all this, how to test it, how to debug it, how to visualize, even teleoperation tools, because sometimes you need human in the loop. That's actually been a learning from the automotive self-driving car industry, AV, that there's often a call center in the background helping these Waymo cars get through those surprising things when there's a construction or something's changed. And so we've built tooling for that as well. I wanted to show you some videos just to give you a more grounded understanding of the kind of things we're working on. So we're not a overhyped humanoid company, even though they're getting the funding. I and many other people think that we're not ready yet for that. That doesn't make sense for most applications. So we're really big into wheeled humanoids, or industrial humanoids, we like to call them, or just mobile manipulators, as we used to call them. So this is a bathroom cleaning robot. You see it's changing end effectors. It's doing multiple tasks. It's localizing itself. It's navigating through this bathroom. And this is one of our customers that we've enabled with the MoveIt Pro platform. This is an internal program, the classic fetch me a beer. We had to build it, but using 2 arms, which is bimanual robotics, has typically been a very hard problem. We've done a lot of work with 2 arm systems up to 4 arm systems, synchronizing that with the calibration of when you have a moving robot, then you can't assume you know where everything is. You have to do a lot of state estimation. This video shows combining with different machine learning models and sequencing it all with a behavior tree, which I'll talk a lot about later. Other customers in order fulfillment, palletizing. If you go to a robotics conference like Automate, you'll see lots of these being done now. This one has a shared torso, so this required some very fancy kinematics to control both the arms and the shared midsection of this robot. And there's a wheeled version of this that I don't have a video of that is available as well. And so a lot of our stuff, again, is in a mobile moving robot. This happens to be like an airplane hangar. Some of our customers are more in the aviation space. This is demonstrating like a kind of a scan and plan where we scan the contour of a plane and then we move the robot back and forth. So these are just examples of things that we can do. This is a pharmaceutical digital twin that we did for a customer. We do work with BMW. They're one of our big name brand case studies that we're proud of. Doing some pre-assembly and like grasping from a chaotic pick, which you have a bin full of unstructured parts, and putting those in an exact place. Order fulfillment, we've done some work with customers doing like pulling a tote out of a shelf, grabbing the right SKU or product number, fulfilling orders. I think someone here from Fanuc, so here's the yellow robot. This was showing some reachability analysis tooling we did, but we do a lot of work there. So some of the screenshots you just saw were just showing you a recording of a robot doing something, but most of them were actually in the user interface of MoveIt Pro. And so I'm going to go a lot deeper into what that looks like. The history, though, interestingly, this might surprise you, but this was all originally developed for NASA. I guess there's a lot of companies that start that way. So our earliest designs back in 2020 were the problem set of the Robonaut 2 robot. It's a humanoid back before humanoids were cool that they actually launched the International Space Station using an early version of our software. So we have been to space. And we worked with our UX designer to develop this whole set of workflows for having multiple robots, including free-flying, floating robots, low gravity, right? As well as humanoids. So we have this fleet of different brands of robots doing different types of autonomy in space. So you still have a human in like at Houston, the mission control, doing some level of teleop. And we can do that when you're at low Earth orbit, which the ISS is, because the latency and bandwidth isn't great, isn't that bad. But our real mission that we continue to work on with NASA is for the unfortunately recently canceled Gateway station that was going to circle the moon and then on to Mars. So moon to Mars is kind of the focus, although we don't know right now what the focus is for NASA. Unfortunately, things are in flux, but these were the original designs. And so we really looked here at kind of a timeline view. So one of the original inspirations was kind of when you edit a film and you have the audio track and you have the different splices of videos and effects and text overlays. That was kind of the original inspiration that we were looking at. And so the idea being here, we'd have like a timeline and a list view. And so we did some prototypes of this, and we realized that this didn't actually give us the flexibility that we wanted for a lot of different branches of logic. So as we were like prototyping this, if something fails, you want to have error recovery and automatic kind of like go for a loop and keep trying until you succeed, or after 5 tries, switch to this more primitive algorithm. Or one scenario that we really have built out a lot of is, let me try several times and then fall back to a human. So we'll switch to a call center. So this was an original thought that we ended up ditching. And so in 2021, so it's a year later now, this was our first, is this not playing? I guess not. Yeah, our first version was built in a Qt app, which was, it's a desktop application, pretty ugly, but we brought this to the X Prize. It was a robotics competition. This event was in Florida. We made it to the finals, but then decided it wasn't worth the investment to compete in the finals, but we did compete in the semifinals and like did really well. And in this screenshot, we were combining both VR headsets, so we're using 6DoF hand controllers, as well as some levels of autonomy. So we could like move to certain waypoints, or you could click on a screen and say, move over there. So at this point, we wanted to really up our UX system. So because Space Force was a customer of ours, we ended up adapting a standard that Space Force uses for controlling all their satellites and secret spy things and spy planes that they have in space. It happens to be open source, their design system. It's called Astro, very space design thing. So these are from their website. This is not our software, but the person we were working with actually was involved in this. So we pulled in this design system, but also heavily modified it. And so back in 2022, we switched to a web app, which was a lot of work. We had to like rewrite everything. And at this point, we switched to like a breadcrumb approach. So kind of like the timeline movie thing I was showing you a minute ago. But at this point, we just sequence through. This is like a human in the loop. So this is showing that you click on a screen to select a handle, and then it does some motion planning, and the robot automatically generates the path. You can preview it, say accept, and then it executes. And so we built a mock-up space station in our office, which was really fun, but not fun moving it to different trade shows. We moved it to a couple, and it was quite difficult. But it was fun having this whole space robotics program going on. At this point, we also had integrated logging, which we later removed. We realized from feedback from our developers that they really wanted to use like just native logging tools in Linux and available in the ROS ecosystem. So that was an interesting learning of like, we actually built too much there and decided to remove it from our app. And so as our product evolved, and you can see from here, we're calling it MoveIt Studio. We realized that we needed to move away from teleop and actually focus on full autonomy, because other than NASA and Space Force and the space applications, most companies, to get the ROI, they really want to have something that doesn't require humans being paid, depending on how dangerous the application is. And so at this point, we now have a platform that you can build fully autonomous applications with behavior trees. But we still do have a lot of teleoperator capabilities. So we go from very manual, which is just basic joint jogging, to Cartesian jogging. You can control the end effector of your arm, up to a thing called interactive markers. You can click on video feeds. You can save waypoints, up to like a full autonomy where it's just using its cameras and logic to reason on its own. And so we integrated things like scrub bars where you can move back and forth to preview the trajectory to decide whether or not we like it. And if you do, you can do something like approve. And so this is kind of the evolving approach. So for those teleop, this is the most recent version. It's gotten really detailed through, we're up to something like 30 companies using this platform. We've really had to build a lot of different features. So there's the waypoint following, which is what you might think of as a teach pendant, where you just save a joint state and say, I'm gonna go to here and then there. So we got that. The second screen, so this is actually 4 different UX screens. This is the eye marker approach, but you can also plug in any USB controller, whether it's like an Xbox controller or off-brand, as well as we have support for a haptics device. This gives a 6-off control. So that's kind of the eye marker approach. We have the ability to pose the jog in the UI using these buttons, and then finally the joint control. So that's all everything about teleop. I'll move on from there. And I think there'll be time for questions at the end. So yeah, I wanted to bring in some design principles that I can't say that we actually thought about these ahead of time, but I wanted to match what we ended up building with some of these Nielsen's design principles. They actually came out in 1994. I was asking like our UX designer, what were you designing against? And she was like, okay, these are the things that we brought in. So I'm going to sprinkle these through the next slides as we talk. But this is a highlight of the developer platform. And so there's basically 4, you can optionally have up to 4 panes. You can also have multiple windows. And so we've built in a visualizer to let you see what the robot's thinking. And that's kind of like if you happen to be in the ROS ecosystem, what you would call RViz, or if you use maybe a software called Foxglove, it's kind of equivalent to that. We have a built-in behavior tree editor and viewer, so you can see at real time where you are in the behavior tree, which is kind of like a state machine. And then we have the ability to feed in cameras and like camera feeds. And most of our offline work, we're using a simulator. And so our camera feeds are just views of a simulation, a high fidelity physics simulator. But when you connect to real hardware, you can have 1 to, I think it supports up to 4 camera feeds, as well as you can see depth camera data. And then it also serves as kind of like an application launcher. So on the left here, what we call applications, we call them objectives. And you can basically run a bunch of different applications, and it can switch without having to like restart the software, without having to go to terminal. We have the ability to like have these different favorites, customize the scene. So I'll get more into that here, but we really wanted to make this platform really flexible and efficient for your workflow. And so some of the things, I could, at this point, switch to a live version if that makes it more exciting for you all. Let's see if this is running. Yeah, okay, so we're live. So this is one of the worlds. This is the pharmaceutical world. And in terms of like flexibility, it just lets you switch between different viewing modes. And I could switch between like moving a pane left to right. So we have buttons for that. We have buttons for making it full screen quickly. And so we really wanted to make the developer workflow easy to zoom in, because in particular, when you go to the behavior trees, these can get very complex. This looks simple, but these are actually subtrees. So if I expand them, they actually get quite large. And so it can support a very detailed amount of robotic logic here. And so if I zoom in, this is a very simple one that's called scan scene. So it just moves the robot out of the way and it takes a picture of the point cloud, but there's a lot of different things that we can do. So let me show you, I'll just run this again. You can restart this, and the robot's gonna move out of the way and take a snapshot of the world. And so now we have this point cloud, and I can maximize that to show you. And so these are some of the tools that I just kind of want to say, like, let's see, helps with the flexibility. And we also, you can open multiple screens, you have multiple monitors and all that. So they have this Nielsen framework of these 12 ones. One is like making it clear to be able to match between the real world and the system we're controlling. So we want to make this a really visual experience. And so not only do we show you the visualization, but we show the simulation, and you can also match that to the camera feeds. I didn't pull in the camera feeds here, but I think you saw in a lot of the earlier videos that we've done a lot of this connected to the real world. So this gives a lot of immediate feedback. Let's see if I can run a different application example here. So like a pick and place example. The robot's picking up a block. Yeah, so here's one where we're gonna move a bunch of flasks over from this onto this burner. So just a bunch of examples built into the product. And this is all like, yeah, this is a live demo, so if it breaks, that's the risk. One thing we wanted to really focus on is how do we shorten the cycle between testing something, like building something as a roboticist, and testing it in simulation and hardware. And so we put a lot of thought into you can drag and drop and edit your behavior tree, and then click this run button on the left here, see it run in simulation like I just did for you guys. And if you don't like it, you can click the edit button. So this just moved all 3 beakers. We click the edit, and we drop into this edit mode. And so now I actually can move these around and say I want to delete it. I can remove that, for example. So just really shortening the cycle for roboticists. Historically, it's been a lot of like writing some code and compiling and then launching and changing all these like command line arguments. Another UX design principle is the ability to make mistakes. So I actually just use the undo redo feature right here. So we have that integrated. I don't think these niceties, they seem so basic in like a Word application or a spreadsheet editor, but this is something that's not, to my knowledge, been super available for robotics before. So we have things like that. And then the error recovery is a big one. So when you've either misbuilt your behavior tree in your application, or the motion planner fails because it's not understanding the collision objects or whatever, we have, I think, fairly clear error messages that pop up to tell you what's missing, and it actually highlights the box and tells you this is the one that I failed on, and you can zoom in and kind of understand what went wrong there. I'm not sure if I could like show a simulation of an error here. We worked hard to make these not break, but yeah, this is a screenshot. I'll just stick to that. The application is split between 2 primary modes. There's the build mode, which is the developer mode, and then the run one, which is not only for testing your application, but you can also think of it as maybe an operator. So you can use our software as an operator interface. Most of our customers choose to build their own UI on top of this that's much more custom to whatever domain they're in. So because we work across a lot of industries, they might have different words for, if you're running a manufacturing line, you care about cycle time and like how many parts and the quality control. And if you're running a underwater submersible, you might be thinking about, you want to display the depth of your submersible and the water flow and how it's pushing you off of your you're like, I forget the word for this, but when you're station keeping, that's the word. So yeah, I'll go back to the live demo. So up here we have these two build run modes. And I'll talk about in a minute how those have evolved. Yeah, here it is. So minimalist design, we've been through, I'm not sure this is too much detail, but we've been through a lot of versions of our like navigation bar. We're actually working in the next version, doing it again, like changing it. So you saw in that first picture, really bulky design, kind of embarrassing look back. And then we started like actually putting in the main menu all of the different teleop modes, whether it was different kind of manual control. And then we realized that we didn't want that to be the focus. And so we've since moved that all to this teleop button over here, so kind of hiding it. And we've gotten currently to this very minimalist design. And then our next thing is we want to take two different toolbars. So there's a main navigation bar and a sub-navigation bar. We actually want to combine those to maximize screen space. And so we have that mocked up in our Figma designs, not implemented yet, but this is a sneak peek there of what that's going to look like. So yeah, not sure if that's as interesting. In terms of system state, that's been a big one. So we've made sure that we show you if it's executing, if it's been canceled, if it failed. We have a lot of status there, as well as in the behavior tree. You could see it at runtime moving through the behavior tree. So let me run a different application here. So let's push a button. And if I switch to the behavior tree, you can see it stepping through these steps. So right now it's moving and then it's gonna be complete in a second. So yeah, now it's done. If I wanna restart that, we'll see again, it starts up here. Some of these it runs through really quickly because they're just simple like transforms that like are no time at all. But it starts with closing a gripper, and then it's gonna move to a waypoint and so forth. And you can, if you wanna see it live, this is what it's thinking. Looks like we got an error. So I ran it twice in a row. There you go. So it pops up saying that there was a gripper action. I happen to know that this is an issue with our simulated gripper having issues sometimes. But yeah, no big deal. In terms of this Nielsen number 7, one of the rules is flexibility and efficiency of use. One way we've done that is we have a favorites bar to get to the applications you use most often, totally customizable, so you can kind of favorite different ones, and it'll show up here. And so different customers have different needs about what they use more often. So you can think of these as like, you can have diagnostic tools. So like you want to run a calibration routine, that could be one of your objectives. If you want to go home to recharge your battery, that could be an objective. If you want to calibration diagnostics, maybe you have different types of things your robot's doing. One might be like, today we're running a manufacturing line that's going to move parts over here, and tomorrow we're going to be doing a cutting application. So you can have a lot of different types of applications running at once. Another example of flexibility is that we put in a categorization system, so you can make your own categories or categorize different applications to whatever your heart's content is. We haven't forced that for you. So next thing I want to talk about is behavior trees. This is the core of how we build applications. We encourage our customers and we train them on how to like build their own code in these blocks. So it's very extensible, but out of the box, it comes with something like 200 behaviors. So this is this is our screen for making new objectives itself. And yeah, so here's the 200 that out of the box, you get lots of ones for machine learning, although that space is moving so quickly that as soon as we get a model in, it feels like it's already out of date. Some more of a classic perception around point clouds, processing, lots of motion control ones. And we really don't think we should like throw out lots of reliable classical control models that you can verify, that you know are safe. We think combining that with machine learning is the kind of the way to do things still. We have things around force sensitive motion, navigation of your wheeled robot, grasping. So those are all coming out of the box. Here's a cool feature where you can pull in a breakpoint anywhere in your behavior tree. And then if you run it, it'll actually pause and let you kind of analyze the state of things. So like you might see in VS Code, breakpoints are supported in behavior trees here. And so it's going to pause in this Git video right here, and it gives you a resume button. This also lets you, in robotics, there's typically a lot of magic numbers that I was originally taught during my PhD program, but like numbers you have to tweak in terms of like not just speed, but like how many attempts or how much force, or in this case, a blending radius, which is a very industrial robotic arm approach. And so we let you edit those things in a UI here, although everything's also saved in YAML files in the back end. So it's all plain text files if you wish. And we've built everything. All the features of MoveIt Pro have been built with behavior trees. So even like our teleop capabilities, this is the tree that's running that. Or like we have reachability analysis tools to see if your robot can reach. All that's built in behavior trees. The ability to like record training data for your machine learning models, all built in behavior trees. So it's behavior trees all the way down. We've also recently launched a parameter view that lets you see the data being passed between these blocks in real time. So you could see it changing. In the world of behavior trees, those are called blackboards. So that's another way that we let you introspect and debug. I'm smelling pizza, so I hope that's not too distracting to you all. One of the things that we had a problem with is as our library continues to grow behaviors, we're having a hard time making that people find the ones that they want and reach them quickly. So we've been putting some UX tricks in there. So the first way that we let customers find them is you can just like expand them all and kind of scroll through all these categories. So we had to build a category system, and then we show. You can like just kind of scroll through and hope you figure it out. When you highlight on them, they'll show you a description of what each one does. What we're about to release on our next version, I think on Friday, we finally added this like pop-up thing I'm very excited about. So now you can, instead of having to drag and drop from the left sidebar, you can just do a quick search and it automatically adds it to exactly where you want it. That's a long overdue feature, but trying to make the ease here. So now we give you both options. You can search on this left bar at the top as well as search inline here. Another experimental feature we have is you can actually tell an LLM what you want. And because we have a lot of metadata, we have tons of example objectives. We've already built a bunch. And so we add that as training data. And we have a lot of metadata like descriptions. And so it doesn't always work. And you know how it is, like it's still experimental, but we are working on getting more and more value out of just write a sentence. We haven't hooked it up to a voice to text, but that's pretty trivial. So this actually we think this could result in, as we build this feature out more, LLMs building it better than we can. And like a lot of these machine learning models struggle with like nonlinear systems. So a robot arm, because you have like 6 or 7 degrees of freedom, you might have the wheels. It's a very complex system. And in order to be fast, like fast cycle time and efficiency, we really think the classic algorithms are the way to go. But we can have the LLMs orchestrating it and combining it together for us. And so we're really excited about this direction. It's still a little research for us, but we have that in there. One thing our customers, especially on our sales calls, they struggle from is they see this as a no-code platform, and they call it like Simulink, and it's sometimes or LabVIEW, and it's like a bad word, but it really is a developer platform. And so I wanted to talk about how so. Like first, we use ROS tooling extensively, and that could be a bad word for some people, but we've really had a lot of success with production systems on ROS. We're leading a group called Space ROS, where we're qualifying it for space flight. ROS has already flown, by the way, but not with astronauts, not to like a Class A mission but yeah, we've had a lot of success with putting it not just in space, but like all sorts of ground applications. We have it on oil rigs, we have it underwater, so like, yeah. And so because we're using ROS, you can use all the typical ROS packages, although there's different qualities of ROS packages. If you're grabbing grad school code, be careful. But we let you write everything in like Python or C++. The behavior trees, you can build them in the XML itself. You don't have to use our user interface at all. And we have APIs at every level where you can plug things in. You can have your own application on top of all this. Our whole application can run headless. So in terms of headless, there's the runtime that your operator front end would connect to, and there's the optional developer platform that we really recommend for building and debugging, but we wouldn't expect you to deploy this to your end customers. So here's an example of an application built on top of MoveIt for MoveIt Robotics. And we also make it really easy to make your own code extensions. So you can do this at command line. We also have this UI where you type in a name of a new behavior or a new plugin you want, and it just creates a bunch of boilerplate code in your code base in a ROS package. You just hit compile, it runs without doing anything, but you kind of need to fill in the code to add any extension you want. So that's how we've made this really a developer platform and making that easy for folks. We do have some like what we call planning scene capabilities, where you can add collision objects, you can drag them around. So if, for example, if you want to have no-go zones like safety barriers, for dual arm systems, some of the more primitive ones, you just have like this arm works in this space and that space and don't overlap. You can do that with this. we have the ability to add, various geometric meshes, and you can save your planning scene and load it later. As well as things like we have visualizations that give you feedback when your algorithms are failing. So in this case, we told the motion planner to move into an area that is a collision, and so it pops up with these red spheres saying, no go here, like this is not good. So it'll give you feedback of like, okay, this joint's in collision, there's self-collision. So I have to talk about AI because everyone is, and that's what we're doing. So a lot of what I've traditionally, when people thought of MoveIt, is like these motion planners. These are like well-known, verifiable. They're probabilistically complete. So as they run to infinity, they are guaranteed to find a solution. And we think these are still really reliable for a lot of areas. But we've also integrated out of the box a ton of segmentation transformers and graph transformers. They're pretty good out of the box, but you do typically want to add your own data for whatever your specific application area is. And then we use that to then, we use the behavior trees to then coordinate all of this. And we can also use some of the classic controls to make sure it's safe and verified and like not doing danger to folks. And lastly, we have experimental end-to-end models. We're using diffusion policies. Those are also integrated in MoveIt Pro. For this, you really need to train your model per application, but we can actually use MoveIt Pro as a data collection tool. So we have all the teleop stuff I showed you. So it's easy to take human collected data. We can also use our simulator and all these classical algorithms to create a bunch of synthetic training data that you feed into your model, and then it'll like be able to generalize better than, sometimes these like older approaches, they don't generalize well, and that's been a lot of the reason why these companies have failed. And so we do have this AI tool chain where you can either use the pre-built models, this is the column 1, or you can use as a training your own models, column 2. I won't go into details because it's less on the UX side, but yeah, this is probably too much detail. So here again is the fetch me a beer demo, I guess, from earlier. And this is, I will go back to this slide. I'll say you put a prompt in, like give me a beer from a fridge. The LLM will then build the behavior tree using these different components, these green boxes. We put that through a safety check with collision checking, joint limits, force limits, and then that goes to the hardware. So that's the way we're navigating the ML side. That's how we're putting our bets on it. Another thing we're doing is just putting a lot of visualizations for the segmentation algorithms within the developer platform, so you can quickly get feedback if the models are working. On this bottom right here, you can see it's labeling different objects. Classic thing you've seen a million times, but we have that all built in as well. And then so we have behavior trees orchestrating ML models, and like I said earlier, the ML model is orchestrating behavior trees, so it's many layers of ML now. I love thinking about that. It kind of confuses me. Yeah, about done. In terms of future work, I think I just have one slide here. So areas that we haven't built out the UX for that I'm excited about is really the onboarding experience. Right now we have very extensive tutorials of how to set a new robot up, but there's hundreds of robots out there. Our stuff is robot agnostic. A lot of our customers build custom hardware. Others use off-the-shelf components like this you are pictured here. But we don't have a setup assistant, a streamlined way of importing like your SolidWorks file, your CAD models, and setting it up all in the UI. We've mocked up the models. We just haven't been able to prioritize it in our roadmap yet. So that's a big area for our UX designs to really expand, is like easier customer onboarding. The way we get around that right now is when you buy MoveIt Pro, we include 2 weeks of consulting from our team, and we help you kind of like configure things. So it's a little bit of white glove, and because it's a one-time thing, it's not something that we have been able to prioritize yet. One of the last things about this Nielsen UX designs is learning and documentation. So we're trying to present the documentation in line with the tool, not having to necessarily go to tutorials. So whenever you highlight on the sidebar different behavior capabilities, it does pop up with this description of how to use it. It also, once you have added it to your behavior tree, if you click on it, there's a sidebar that opens up and gives you that documentation as well. So we've really built that into it. You don't have to click out anywhere. It's still a complex product. Robotics is hard. And so one way to get over that is we, out of the box, ship 6 example worlds, very different applications. So we have this lab sim, hanger sim, and grinding sim. So like smoothing an engine block is what we're showing here. Satellite servicing sim. So there's 2 space vehicles and one grabs the other and does calibration. And It's like low, there's no gravity, so like floating, if you hit it wrong, one floats off. And we don't have any propulsion model, because if we did, it'd be ITAR classified, which is a government protection thing, so we can't put propulsion in, which I think is hilarious. And then we have factory sim, and then this like machine tending example. So we provide you all the code for this, so you can go in and see how it's built and like copy and get inspired from it. We do have courses to learn and tutorials online, lots of how-to guides online, docs and all that. So anyway, in conclusion, that's how we're trying to bring some UI, some like nice debug tooling, some introspection tooling to the robotics industry. We've already deployed this across a lot of customers. When we first built this product a couple of years ago, our team was like a little skeptical. Like some of our team, because we've been around for a while, been around for 10 years. Some of our team was skeptical, it wasn't built out, but it's been really cool in the past couple of years as we've matured the platform. Now our team is like really into it and like using it for everything. And so that's how I kind of judge. I'm Chief Product Officer. The success of this is just seeing our own developers, because we do a lot of deployments of these, a lot of services as well. Seeing them really cling on to this and seeing that shift where now they're like just constantly giving feedback of how can we make this easier and faster. Like one thing I saw today on my travels here, our team's like, we really need to have a way to like right click on a behavior and disable it so that we can only debug a subsystem, and we haven't built that yet. Right now, if you want to do that, you have to like copy it and then like delete things you don't want. And so that's something we're going to add next sprint. If you're interested in trying it or learning more, please reach out to me. I'm Dave at PickNik.ai. We have a number of different ways that we engage with customers. And thanks. Questions?
You talked a little bit about AI, and I know when we were talking maybe a year and a half ago, things were just kind of kicking off. But how has that changed the product? We saw some of the examples here, but would you say on a scale of change, has that been a dramatic shift? And like, how much has that impacted your customers and kind of the use cases there? I'm just curious. There's so much hype about it. We're going to talk about it, but how has it kind of impacted your product and business?
Yeah, great question. It's affected every sales call for sure. Yeah, we have to do a lot of education. Like, I really want that our customers' projects are successful, and you have to like be careful that you don't get sucked into the hype. If you're fine with your product platform solution getting to market reliably in like 10 years, then go for it. Go for just all end-to-end models. And maybe I'm wrong there. Maybe it's 5 years, maybe it's less. But in terms of things that work today, I'm pretty confident from going to lots of conferences and hearing talks, and we follow it closely. And I know a lot of folks in startups doing this. You can get like 80% solutions, and that I think that would be great for like home environments where an 80% solution is okay. But we're just so used to like working in very high stakes, high speed, where you want the cycle time that we hear that so often. Like, how quickly can we unload this truck of bags or whatever? Like that, I just worry that going too far into that right now, you got to use it like the right amount of it, right? Like, it's super powerful and it's going to get better. But balancing kind of classic algorithms with the new approaches is our take for now. That said, we definitely have some folks working on end-to-end training, and we're going to like continue to develop that as well, so that as it gets more reliable and as the next big breakthrough happens, we're ready.
Yeah. So the question I have is, I remember seeing like a case where you said, okay, it hit a bug, or basically it gave you an error and one of the boxes became red. Is that an offline case, or does that also happen while the robot is actually running?
It could be either.
Okay,
for sure.
But in the case where it is online, is the loop closed only by a human, or do you have a way of attaching, let's say, a VLM to resolve those issues automatically? You know what I mean? Basically, a camera watching the robot hit an occlusion and change the decision tree or behavior tree during runtime to resolve that issue, etc. Like, can you put a model in the loop at that point?
You might be able to. We're not doing that right now. Okay. So right now, when you get an error, it's the developer, the roboticist needs to go in and like fix something. And if you're in a production system, then yeah, we'd have like the kind of remote human be able to fix it. But as we get closer to a production system with customers, like we just, you like any software, you just weed out the bugs and get it more reliable. Or sometimes you have to change your assumptions about the system. Like there's typically things you can do to simplify a problem if you're having problems like that. But I mean, it's a good idea. It's as this develops more, maybe a VLM could automatically correct itself.
One clarification though, this system, if I'm understanding correctly, only works in a fully static environment. Like if one of the things you designed for moves, if one of the obstacle moves basically, or if it's placed incorrectly, then your program doesn't work anymore.
We do a lot of systems that are like visual servoing, dynamically tracking, moving objects in real time. That is certainly an area we work in. So yeah, we can definitely handle dynamic environments. There's more challenges and more complexity to it, but that is a thing we do.
I just had a quick question about the end user. So, typically we see these applications targeted towards robotics engineers, and this is a step towards non-robotics engineers. Who is your target end user whenever you started this, and has it changed dramatically? And where do you see it going, as an end state? Is it going to be, random person off the street? Is it like factory worker, maintenance person, et cetera? Like where do you think the limitation is of, this interface?
Yeah, we still target like software developers. We're very clear internally, like you don't need to use our software, you should not need a PhD. And so if there's something that requires that level of complexity, we're doing it wrong. And the reason why, like, there's still some, like, there's variables passing data between states, and so I think with like the LLM building the behavior tree, as that matures, then I think we could reduce the burden on it. But there's typically an engineer in the loop, so you can think of this as a tool, kind of like MATLAB or something, or SolidWorks. But then in the run mode, like, there's like kind of an operator side of it, where anyone can run different applications, and if it fails, kind of restart it. So that was certainly a lower bar for folks. But that's kind of our current thinking. And then I mentioned earlier that you might put your own user interface on it that would make it more usable by any kind of user. I think the first question you asked was, what did we originally expect? So I mentioned our history was kind of like a NASA control system for space robots. And our target user there was a very educated operator at Houston Mission Control. That was kind of our first thinking, but we've certainly have like kind of pivoted away from that to just anyone who wants to build a robotics application.
From your presentation, so thank you for that. My name is Hemant. I'm an AI ML product manager, and I'm interested in understanding the LLM. Like, is it a homegrown LLM system? Can you elaborate on that? What kind of LLM is it? And it requires training data and test data. So I'm curious about if you can kind of elaborate on that, please.
So the diffusion policy model is homegrown. We just collect a bunch of instances of a robot arm doing whatever task. A combination of human demonstration and synthetic data from the rest of this infrastructure that I've demonstrated. And then the LLM the experimental LLM for building behavior trees itself, that's just an off-the-shelf one. And we're trying different ones, but it is, early. To be honest, we've been doing this for 10 years, so like it just like happened so quickly that we're not doing our own LLMs yet. Yeah, good question. This is the last question.
Sorry, one last question. Okay, so in terms of, I saw your factory simulation, which you have over there. What are the limitations in terms of real-world equipment that you're able to bring into this? And especially aging factories.
Aging factories?
Yes.
Yeah. We found the sim-to-real gap to be really small. So we actually build almost our entire application in the sim now. And then we'll, like, depending on where the customer is, we'll fly out and work with them. And usually we're there for 5 days and it's like fully working. It works on any brand of hardware, including like Ally that you guys mentioned earlier. That was a customer of ours as well. And the tricky part is just like, for most of our customers, we use ROS. We don't have to. There's another version that is you lose a lot of functionality without it, but the ROS driver is a prereq. So if you don't have that, then there's additional integration that can get kind of complex, just in terms of like real-time control theory, and all of that. But yeah, I guess the other limitation is like for older equipment, they just need to have a decent API. So I work with a lot of manufacturers of robotics, and I do a lot of kind of lobbying there, trying to get them to be more open with their APIs, but some vendors aren't, and that makes it really hard if they don't expose control there. They're kind of like a walled garden approach. So yeah, good question. Appreciate everyone's time here. Thank you so much.